photoelectron. So there are two things are there. No? Just you directly go for it. One, photoelectron which is ejected with maximum kinetic energy, and another photoelectron which is ejected with zero kinetic energy. So this is K1, K max, K2, 0. In your entire discussion, it must come like this. This is the emitter. This is a collector, and this is a photon. Lambda you just shown here by it. Photons of energy 5 electron volt. These are photons. So we know energy of photon. So find the work function of the metal and state whether the current in the circuit is less than or equal to saturation current. Now what is telling? Electron reaching the anode of kinetic energy is varying from 6 to 8 electron volt. Let's do one thing. This is applied potential difference. No? What direction E bar will be? E bar must come in this direction. And any electron here in what direction will experience a force? It will have some kinetic energy, say K dash, and it will also experience electrostatic force. We'll agree this. So by the time, so now there are two electrons. So one electron will strike with how much of kinetic energy? 8 electron volt. I'll give some color for it. Yeah. Next, another electron. So there's one more electron is there. So that this is a range of kinetic energies of electrons striking the collector. Let's analyze anything from here we can determine.
Max 2.
Yeah. Let's other think. Let other think. So don't give answer time being. Let others analyze. Okay, we'll do one thing. For 8 electron volt, we'll write equation. 8 electron volt. What is that 8 electron volt? How that 8 electron volt it has come? It was ejected with kinetic energy K1 max, and electrostatic force does work, no? Then it has become 8 electron volt. So K1 plus work done by electrostatic field. Then it has become 8 electron because the electrostatic force does positive work on this charged particle. So come for this 8 electron volt. K1 what you can write? HF minus work function or energy of photon plus work done. What is work done by electrostatic field? Charge into potential difference. So shall we write this is some, okay, V not any symbol. Shall I write E into V cell? This should be so 8 electron volt. Energy of photon how much? 5 electron volt. Work function. This will be E into 5 or 5E you write it. I think this will be what is the work function of the metal? 2 electron volt. I got the work function of the metal. Next after this, find the work function of the metal and state whether the current in this circuit is less than or equal to saturation current. Now tell me, let's go back to saturation current. What do you mean by saturation current? When all the ejected photons reach collector, then it's a saturation. Will I agree? Sir, how do we can say with that? How do we can say that? Okay, let's do one thing. At saturation current, if saturation current is flowing, so here the current will flow like this. I wanted to check is this current saturation or not here. Okay, let's do one thing. Those electrons which are ejected with zero kinetic energy, so when they get accelerated by this electrostatic field, when they strike this collector, how much of energy they must have? So zero electron, I'll show like this. There's a zero electron. Zero electron, already I'm there, no? So zero electron, will it reach this particular thing? So is it the zero electron only after getting excited will become 2 electron or no? So what's happening here? Suppose like a how much of like a kinetic energy what when the zero electron should acquire how much of energy they should acquire when they reach collector? 5 electron volt. Able to make it out. I don't have any equation, just I have to put it in very conceptual way. I have to explain this one here. You do one thing. What should be the energy of photon? 5 electron volt. Come for this. Then what is the maximum kinetic energy of the electron? 5 minus how much will be 3 electron volt. 3 plus work done by the cell, 8 electron. This is the maximum kinetic energy. Zero kinetic energy electron, if it get accelerated by electrostatic field, then by the time it reach collected, how much of energy it must have? It must have 5 electron volt. Am I right? But how much it is having? 2 electron volt. So what happened here now? The zero kinetic energy electron are not reaching it. So therefore, instead of this K, so the zero electron volt, I'll show it here, and they are unable to reach. So this K is what reaching there. The zero electron volt or zero kinetic energy electron volt what when will be at rest and will continue to be at rest. So I'll do one thing. K equal to work done by electrostatic field. So this 2 electron volt, how I can write it as 2 electron volt, red color.
6, sir.
Which one?
That is not 2, that is 6
6 electron volt.
6 electron volt. So, yeah. 6 electron volt should be equal to what? K plus work done by electrostatic field. Keep it as it is. K. What is work done by electrostatic field? Already we know. 5 electron volt. So therefore, what is the? This will be 1 electron volt. So the kinetic energy with 1 electron volt will, when it reaches collector, will have 6 electron volt. So definitely what happens, the zero kinetic energy electron cannot reach there. Because what is the kinetic energy of electron when it reaches here? 6 electron volt here. Zero kinetic energy electron, if it reaches here, what should have been this 5 electron volt? If I wrote this 5, it could have justified. Will I agree all of you? So with this, what I can conclude here now? Those electrons, those photoelectrons which are ejected with kinetic energy less than 1 electron volt will not reach collector. Now, is it all the ejected photoelectrons are reaching collector? The answer is no. So therefore, is it current saturation? No. The current flowing is less than saturation current. Fine. I think it's all about the the work done. The energy equation you should write properly. Go back to the basic electrostatics, apply things clearly. You can manage any of the questions. Even if the energy of the electrons reaching collector was 5 electron volt, then what is the conclusion you can make it? As then it's a saturation current. Means now you have to ask question. Sir, this field is there. So this will not exert any force. Then this should move. No, it should have sufficient strength. Then only the cloud charge will move. So for any non-zero applied potential difference saturation current flows, I think the answer is wrong. So when the space charge layer will diminish totally, it will become zero at certain potential difference only. Got the idea? So theoretical questions, very good type way of asking questions are there here, that one. So you have to be very alert here, theoretical things. I'll go for next question.